We already know a lot about wireless communications in the form of Wi-Fi, Bluetooth, near-field communication, and RFID tags. But there are some other things that we should be aware of for wireless device connectivity, one of which would be things like GPS, Global Positioning System. GPS uses satellites to track, based on coordinates, longitude and latitude, where an object is on the Earth's surface. There's infrared. Now, infrared wireless technology is considered legacy, and that means it's kind of older technology that isn't really used anymore. Infrared is line of sight. Think about a remote control for a television. You have to be line of sight. You have to be able to see it and make the connection for the receiver in order to remotely control that television. But on the computing side, that was traditionally used in the past to interconnect laptop computers together, maybe to transmit files, maybe even to connect a computer to a printer, so both would have to support infrared. But you just don't see it around very much anymore. Then, of course, we've got cellular communication, making phone calls over the cellular carrier network, or sending SMS text messages, maybe even sending multimedia content like pictures and video along with SMS text. We already know about Wi-Fi and Bluetooth and NFC, so those we've covered. So let's talk in detail for a second about GPS, Global Positioning System. So it's a satellite navigation system for object tracking on Earth. Now this is called a point-to-multipoint type of communication system. Anytime that you've got satellite communications, whether it's for television, whether it's for internet communications, for ships out at sea, whatever the case is, the point, the individual single point, for example, might be a ship at sea, but the multipoint would be all of the satellites it potentially could make a connection to. And in some cases, it can have simultaneous connections to more than one satellite at a time. So the GPS receivers then use what's called triangulation to actually pinpoint the location of something on Earth, like law enforcement trying to track an offender's smartphone. I don't know if you know who Kevin Mitnick is. He was caught in 1995 by the FBI through cell phone triangulation. But he now runs a security consulting firm. Go figure, it actually makes sense. Now, the security implications of GPS are really simply don't enable it if you don't need it, such as on your smartphone. Now, sometimes having GPS on a smartphone is good because you need to be able to track your location relative to maybe an Uber drive that's coming to pick you up. But in other cases, for example, if you're a military official on a base that shouldn't really be made known to people around the world, you probably don't want your personal smartphone with you with GPS enabled. There are potential ways, depending on the sites you visit on the internet or the apps you use, where the location of that military base might be made known. And we probably don't want that to happen. So don't use these things when you don't need them. We've been saying that for the entire series. Disable unnecessary services and configurations. Cell phones these days are ubiquitous. They're everywhere. Pretty much everyone has one and uses it to communicate in many different ways. But when it comes to actually making phone calls, we're still using radio frequencies. We're still sending radio waves through the air. Just like you are with NFC, mind you on a very small basis though, compared to cellular, same as we do with Wi-Fi, Bluetooth, it's all radio waves going through the air. These are just all different standards on how that is used. So when we talk about narrowband radio frequencies, we're talking about a small range of frequencies that are available. When we talk about broadband, we've all heard that term at some point, we're talking about a wider range of frequencies. And the interesting thing about broadband as a term is it also means that we can have multiple transmissions at the same time, just running at different frequencies, hence broadband. So when we talk about cellular networking and cell phones and cell towers, a cell you can think of as being the radius of transmission signals from a cell tower radiating outward. Now, how much distance does that cover? Well, it varies, but generally it's about 10 kilometers, which works out to be about 6.2 miles, give or take. Now, when we're dealing with things like smartphones, of course we know that we should update the software on the smartphone, so updating the OS, updating the apps. So when we need to update the firmware in a smartphone, that normally uses a technique called firmware over the air or OTA updating. All it means is you're pulling down updates through a wireless network connection. And that would apply not only to smartphones. If you've got an Apple Watch and you're applying updates to it and you're not plugging it into a device that has the updates, again, it's a firmware OTA update, over-the-air update. Now let's take a look at a sample of a cell tower coverage map, specifically in the region that I'm located in. So here in Google, I've navigated to cellmapper.net, where on the left, I can select the provider whose cell towers I want mapped or plotted geographically on a map, and I can zoom into and out of the map. So as I start zooming into the map, I start getting more details about where those cell towers are. They're showing up here as mostly red circles. And I have some details for each of them, like the different communication channels or bands that are enabled on those cell towers. Now remember that if you're more than, let's say, 6 or 7 miles away from the nearest cell tower, it doesn't mean you won't get a signal, it just won't be optimal. So when you're looking at your phone, you might only have 1 bar instead of 4. Although don't really trust those bars because they aren't fixed to a technical standard. Each carrier seems to do it a little bit differently. So just because I have 1 bar on my phone and you have 3, doesn't necessarily mean you have a better connection. Anyways, as we take a look at this map, we get a sense geographically of where the actual cell towers are. So let's say, for example, if I zoom back out here and, I want to spend the weekend at the lake. So if I start taking a look at this province on the east coast of Canada, Nova Scotia is the province, we've got some pretty big lakes here, but as I start zooming in, it looks like a lot of the cell towers are around the cities, around the coastline. There's not a whole lot of cell towers on the interior in this particular part of the world. So this can be important just to get a sense of what kind of range you have. If you're kind of out in the wilderness and you need internet connectivity, let's say, you could enable that on your smartphone, but if you don't get enough of a signal, you can still get cell tower boosters. And what it does is it gives you a 30 or 40 decibel type of gain on power so that you can actually get a reasonable connection where otherwise, without that booster, you wouldn't. So cellular carriers around the world are currently busy updating the cellular network infrastructure to 5th generation, otherwise called 5G, which supersedes, of course, the current standard of 4G. One of the benefits of 5G, at least theoretically, is transmission rates up to approximately 10 gigabits per second. That's pretty fast compared to what we're using now. But the other thing to think about is that 5G cell towers have a smaller signal range. And so instead of having about 6 miles with current 4G cell towers, we have a transmission range of about 2 kilometers, which works out to be about 1.2 miles. That means they're updating their infrastructure, the cellular carriers are, meaning they need more cell towers. Now the base stations, these are the stations at the ground at the bottom of the cell towers physically, are designed in 5G to have very fast, a lot of bandwidth input into the network. So that means it's using fiber connectivity at the base station level. Now in order to partake in a 5G network, some people might have to update the devices they're using, like their smartphones. In other cases, you might still be able to get away with the phone that you might be using today. It might support both 4G and 5G, but it's something to be aware of. Another network standard is Wi-Fi Direct. You can think of this as a peer-to-peer connection over a Wi-Fi network that is defined only on the 2 connecting devices. In other words, you don't need a Wi-Fi access point or router, and also it doesn't have or doesn't require internet connectivity. We can simply have these 2 devices talking to one another over Wi-Fi to transmit files. It might even be between a device and a wireless printer to send a print job over Wi-Fi Direct. So in our diagram, we have those 2 examples. We have a smartphone user printing directly to a Wi-Fi Direct wireless printer. And also we have in our diagram 2 smartphones communicating directly without going to the internet, without a wireless access point, to share data. So there are a number of ways then that we can allow communications between wireless devices. The last thing to consider when it comes to connecting mobile devices is mobile device tethering. What this means is we can share an internet connection that one device might have to the internet with other devices in the local proximity that might not have their own internet connection. So imagine that there's no Wi-Fi hotspot where you are, but you have a data connection to the nearest cell tower through cellular networking through your phone. You can enable tethering either wirelessly by setting up a Wi-Fi hotspot on your phone that nearby devices can connect to. So your phone is just acting as a wireless router. Now, while that can solve some problems and certainly can be used legitimately, this goes back to the example we talked about way back when we said that in a coffee shop, for example, a malicious actor might enable a Wi-Fi hotspot on their phone and call it the same name as the legitimate hotspot in that location. Remember, that's called an evil twin. So there is a relationship then with mobile device network connection tethering and security.